Welcome to Chapter 11, the chapter devoted to the volume and surface area of solids in the Pearson Geometry video series. Let's talk about solids. In fact, let's start with polyhedrons. Go down to the bottom here. A polyhedron is a three-dimensional solid, whose faces are all polygons. A three-dimensional solid whose faces are all polygons. Okay, you remember what polygons are from the beginning of the year? Polygons are closed figures with no curves. Okay, so what are faces? All right, let's go look up here. So we have this huge gigantic dice right here. Okay, it is a cube. So all of these flat surfaces, the flat surfaces on this cube, these are all the faces. So faces are the flat surfaces on the polyhedron. Okay, and then we have edges. And these lines right here where the faces meet, these are the edges. Okay, and finally we have the vertices. And the vertices are these corners. And these corners are where the edges meet. See, you can see how these three corners, or these three edges, all meet at this one vertex. So vertices are where the edges meet. Okay, so all the polyhedron are made up of a set of faces, vertices, and edges. And this brings up Euler's theorem. Okay, so now we're going up here. So Euler was a mathematician who discovered lots of important math stuff. One of his discoveries is a formula that describes the relationship between faces, vertices, and edges in polyhedron. This is the formula. F plus V equals E plus 2. So this F stands for faces plus the vertices, and that is equal to the edges plus 2. Okay, so let's see how we're going to use that. And before you even ask, yes, this is something you should memorize. Okay, so let's apply the formula to a couple of problems. Let's start with this one. A polyhedron has 12 faces and 30 edges. How many vertices does it have? Well, if we go back to our formula, faces plus vertices equals edges plus 2. Faces plus vertices equals edges plus 2. Well, let's go ahead and substitute in what we know. So we know 12 faces, so 12 plus however many vertices is equal to 30 edges, and that's going to be plus 2. So we've got 12 plus V equals 32. So if we solve that for V, which is our vertices, we'll subtract 12 from both sides, and we're going to get our number of vertices is 20. Okay, now let's kind of turn it around a little bit. And the next question asks if a polyhedron can have 4 faces, 5 vertices, and 8 edges. Well, we can check this by plugging it into the original formula that we have. Faces plus vertices equals edges plus 2. So we have 4 faces and 5 vertices and 8 edges. Okay, so 4 and 5 is 9, and 8 plus 2 is 10. And since those are not equal to each other, then we would have to say no. Not possible. Okay, now let's take a look at cross sections. Determining cross sections is a fun byproduct of studying solids. Conic sections come from all the different cross sections of a cone, which is something that we'll get into more at the end of the year and a lot more in Algebra 2. So what I would like you to do, this is a visualization activity. So I want you to pause the video and determine which polygon you think represents each one of these cross sections. And then after you've written it down, then turn the video back on and check your answers. Okay, hopefully you have written down the answers, so let's take a look. So this one right here is going to be a square. This one right here is also going to be a square. And this one right here is a pentagon. Right here, this one is going to be a triangle. This one is going to be a rectangle. And the last one is not actually a polygon because this one is going to be a circle. And circles aren't polygons because circles have curves. Polygons aren't allowed to have curves. So hopefully you got all those right. If you did, then go ahead and give yourself a pat on the back. And if you didn't, I'm sure that you'll be able to next time. All right, last section is another activity in visualization, and this has to do with rotating cross sections. So we're going to take polygon and we're going to figure out what it would look like if it was rotated. Okay, so here's an example. Okay, I have this card attached to this pencil, and if I were to rotate it around, what kind of a solid would result? Okay, so you can tell it's going to be a circle on the bottom. It's going to have edges that go straight up and down, and it's going to have circles at the top also. So what solid has bases that are circles and sides that are straight up and down? If you guessed a cylinder, you would be absolutely right. Okay, let's take a look at another one. This one is a triangle, and if this were to go around, we would have, again, a circle on the base, but now instead of going straight up and down, this kind of comes to a point up here. So what kind of a solid has a circle for a base, but comes up to a point? If you guessed a cone, you are absolutely right, and you deserve another pat on the back. If you guessed anything else, then come back to this later and try it again. Okay, let's take a look at the problem we have right here. If you rotate an isosceles triangle about the altitude, okay, so now it would be like if the pencil was right here and you rotated it around the pencil. What three-dimensional figure does the triangle form? Okay, so circle on the bottom and comes to a point. So we're looking at the same one that we had right here. The only difference is that you're rotating it on both sides. Okay, so we are looking at a cone. All right then, that's pretty much it. And we'll take a look at Pearson's 11-1 skills practice tomorrow. And in the meantime, that's it until then. See ya.